So as we're doing more trig, we're going to start doing some trig word problems now. We've seen a few little trig word problems, but we saw one problem a little earlier in the homework that mentioned things like angle of elevation and angle of depression. So let's review what those things are. Let's talk about that definitions before we move on. So angle of elevation, angle of depression has to do with how you see things. So let's say this line here is my line of sight. It's exactly where I'm seeing on a horizontal. Okay? So we call this the line of sight. And that line of sight is always horizontal. Now, as I look at the line of sight, I could look upwards or I could look down. Well, if I take my gaze and I look upwards, that's called an angle of elevation, is what I've created. So when I look in an upwards direction from the horizontal, this angle here, there's going upwards, is an angle of elevation. Because we're looking upwards that way, okay? If I were to look down on something, so I take my line of sight, which was horizontal, and look downward, now I'm creating a different line. I'm creating a line that's an angle of depression, okay? So this angle going downward like that is an angle of depression. The key is to recognize that both of these angles are being taken from a horizontal line. Okay? So now that we've got that little bit of note of what an angle of depression is and an angle of elevation are, those two different things, let's look at how some of them work on some problems. Okay? So go to our worksheet. We're going to take a look at that. Let's go. So now we're here at our worksheet. So looking at this, let's define these two angles. An angle of elevation is an upwards angle from a horizontal line. Okay, so here's my horizontal line. The angle is upwards. So this angle 1 is an angle of elevation looking up to the airplane. Okay, so using that type of problem, we can now figure out some trig problem with it. So our next problem says, well, Scott, whose eye level is 1.5 meters above the ground. So here's Scott's eye, and that eye level is 1.5 meters above the ground. Okay, that's how high his eye is from the ground. Now he stands 30 meters away from a tree, so there's 30 meters here away from a tree, and he looks up to a bird. There's our angle of elevation. The angle of elevation that he looks up to this bird from a horizontal line now, that angle of elevation has to be 36 degrees. How far above the ground is the bird? So how far, this is what I'm looking for, is this, I'll call it, well, let's just call it X, okay? And that X is this entire thing. Now there's a slight problem here. We've got to move some numbers around. For example, this 30 meters, well, I can move that up to here as well. Okay, because that's going to be the same thing. It's created a rectangle there. Okay, so my right angle is here. Now when I solve this problem, I got to be careful, because what I'm going to solve for isn't the end problem here. What I'm going to solve for is this distance, I'll call it B for bird, right here. Okay? So I can do that since I have my adjacent and I'm looking for the opposite. That's going to be my tangent function. So the tangent factor, I could say, I'll write that in. This is my adjacent side. This is my opposite side. So I know I'm going to use my tangent function. Tangent of 36 equals adjacent over opposite. So now we just need to get our calculator here. And I'll pull up my calculator. So you guys can see that, I hope. Let's see if I can get a little darker here. Nope, let's go the other way. Clear. Alright, so looking at it, my calculator, I'm going to do sine or tangent of 36. So tangent of 36. Oops, that's not what I want. Let's do that again. Tangent of 36 My calculator gives weird answers sometimes. Yours probably does better. So it's 0.7265 equals my 30 over b. Cross multiply. Remember, there's actually a 1 hiding under that. So that's 0.7265b equals 30. So b equals 30 divided by 0.7265. So I'll go back to my calculator and go 30 divided by that last answer. So 41.29. And they didn't tell me what to round to here. So you know what? 41.29. And their measurements are rounded to 1. So I'll round it to 1 since that's what they measured with here. So that's, oops, that's not our answer, is it? That's b. For my x, I have to add b plus the 1.5 above the ground. So that's going to give me, we'll call that 41.3 plus 1.5 gives me 42.8 meters. And all of this new stuff, all of this was old. The new piece, that angle of elevation. Okay, so that's an angle of elevation problem. Let's talk about an angle of depression. Angle of depression, remember we said in our demonstration, was downward from a horizontal line. So when I talk about the angle of depression, I'm talking about, let's see, did I put that on the next page? No, okay. So when I define angle of depression, angle of depression is a downward angle from a horizontal line. So always identify your horizontal line. That's how I like to start. There's my horizontal line, so go down, there's my angle. This doesn't work that way. This is not an angle of depression because my horizontal line is there. Okay? So in this case, this one works. But a big mistake people tend to make is they keep thinking that this is their angle of depression. And that is wrong. Okay? So be careful of that. You want to find that horizontal line first and then go down from there. Let's look at a quick example and then we'll have you do some of your own. So, standing in the gallery of a lighthouse, the deck at the top of the lighthouse, a person spots a ship at an angle of depression of 20 degrees. So the guy sees the ship. He goes, hey, look, there's a ship. But it says right here, angle of depression is 20 degrees. So I need to set up a horizontal line this way. And there's my angle of depression. Okay, 20 degrees. The lighthouse is 28 meters tall and sits 45 meters off on a cliff. So that's a 45-meter cliff. What is the horizontal distance? That's important to know. The horizontal distance between the lighthouse and the ship. So if I create my triangle here, okay, well, let's see. I'm looking for horizontal distance. So that's what I'm looking for. This distance from the, we'll call that all the way down to the water, is going to be the sum of this. I can slide that over here. So the 28 and the 45 add together to make 73 meters. And now I've got my triangle. Some people don't like it drawn that way. Maybe they like the triangle to sit this way. So if you want to spin it around, that's fine. But I'm going to go ahead and keep my picture normal. So I'm looking for the adjacent. I know the opposites. There's my sides. This is the adjacent. This is the opposite. Looks like I'm using tangent again. So the tangent of 20 degrees equals opposite, 73, over adjacent. So I'm going to go through my calculations now. So let's see. The tangent of 20 degrees gives me 0.3640. So that's 0.3640 x equals 73. So 73 divided by my last answer, x equals 200.5659. And this time, we don't have to add anything to it because that is the horizontal distance. Again, they didn't tell me what to round to, so let's just round it to about 200. 0.6 meters. Okay. Now, there's a difference of an angle of depression. Now, there is something neat about this, because if I take a look at how these two things relate to each other. So there's my type of lighthouse problem. Notice that the horizontal lines are always parallel. And the line I use to create my angle of depression or angle of elevation. So that's my depression. That's my elevation. Elevation. Notice that they create parallel lines cut by a transversal, make my alternate interior angles congruent. So that's a neat way to take a look at these. I could take that last problem we did, and now that I see that, maybe I don't like my triangle upside down like this. Maybe I want to draw my triangle right side up. So maybe I want to take this triangle and look at it this way. There's my right angle. If I do that, now this angle of depression I can put here at the alternate interior angle. And now I'm solving the same thing. Okay, so there's another way to look at these problems. Tell you what, you're going to do a little bit of practice now. You're going to do a new thing called a Quizlet, and there's a link on the Google Classroom to go to that. That'll be your homework problems. So do those, and then we'll come into class and we'll do some more problems and talk about this a little more. Two things to remember though: angle of depression down from a horizontal line, angle of elevation up from a horizontal line. So make sure you get that idea right. That's downwards, that's upwards, both from a horizontal. Okay? Try the next few problems on the Quizlet, and we'll be good to go. Have a nice night.